Hello, welcome. Today I will be answering Waec 2016 Physics question 1. The question says state the dimension of A. Impulse, B. Acceleration, and C. Work. Now, to answer this question, I'd like us to tabulate. Let's tabulate. Here we have the quantity. And here we have the dimension. Now for impulse, the dimension is given as m l t minus. For acceleration, the dimension is given as lt minus 2. And then for work, the dimension is given as ml square t minus 2. Okay, so let me just rewrite that one again. Is ml 2 t 2. Thank you. For more videos, I'd like you to subscribe to our YouTube channel www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 2. A projectile is fired with a velocity of 20 meters per second at an angle of 40 degrees to the horizontal. Determine the components of the velocity of the projectile at its maximum height. Alright, now there are two components of velocity at maximum height. We have velocity in the y direction and then the velocity in the x direction. So Vy is equal to 0, and then we have Vx is equal to u cos theta. We have initial velocity to be 20 meters per second, and then we have theta to be 40 degrees to the horizontal. So we have Vx equal to u cos theta, which is 20 cos 40 degrees. This will give us 15.32 meter per second. Thank you. For more videos, visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 3. State 3 different materials that can be used to demonstrate Brownian motion. Now, Brownian motion is one of the evidence of the particle nature of matter, and then Brownian motion has to do with the movement of tiny pollen grains, the way they moved in a zigzag path even though the water appeared to be perfectly still. These pollen grains were supposed to be jostled or knocked about here and there by the vigorously moving molecules of water. So Brownian motion is one of the evidence of the particle nature of matter. So I will go ahead and list the 3 materials that can be used to demonstrate Brownian motion. Number one, we have the polling grain. Number one, we have the polling grain. Polling grain. Number two, polling grains. Number two, we have dust particles. Dust particles. Dust particles. Number three, we have smoke particles. Smoke particles. Smoke particles. We have number four, potassium permanganate, crystals. We have carbon particles, etc. So these are the materials that can be used to demonstrate Brownian motion: polling grains, dust particles, smoke particles, potassium permanganate crystals, then carbon particles. Thank you. For more videos, visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 4. An electron enters perpendicularly into a uniform magnetic field which has a flux density of 0.12 Tesla. This results in a magnetic force of 9.6 times 10 raised to power minus 12 Newton of the electron. Calculate the speed of the electron as it enters the magnetic field. Given that electron charge is 1.6 times 10 raised to power minus 19 coulomb. All right, so given that force is equal to 9.6 times 10 raised to power minus 12 Newton, and then we have the magnetic field B is given to be 0.12 Tesla. Then we have electron charge is 1.6 times 10 raised to power minus 19 coulomb. All right, what other parameters do we have? Now, given that force is equal to EVB sine theta. Remember, the question says that an electron enters perpendicularly. So if it enters perpendicularly into a uniform magnetic field, then theta will be equal to 90 degrees, and sine 90 is equal to 1. So we have F equal to EVB. Okay, so that suggests that we make V the subject of the formula. So making V the subject of the formula, we have F over EB. So that means we have 9.6 times 10 raised to power minus 12 upon electron charge 1.6 times 10 raised to power minus 19 times Tesla, which is 0.12. Final answer, velocity is equal to 5 times 10 raised to power 8 meter per seconds, and that is the speed of the electrons as it enters the magnetic field. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 5. List 3 uses of rocket. Now, what is a rocket? A rocket is an engine or an instrument that produces a great power, more power for its size than any other kind of engine. A rocket is an engine or instrument that produces a great power, more power for its size than any other kind of engine. Now, what are the uses of rocket? A rocket can be used for space travel, for space exploration. Rocket can be used for warfare. Rocket can be used for launching of artificial satellites into orbit, and then rocket can be used for entertainment, that is for firework. So let's list them out. Number one, rocket. Number one, rocket can be used for space travel. Number two, rocket can be used for space exploration. Number three, rocket can be used for warfare. Number four, rocket can be used for launching of artificial satellite into orbit. And then number five, rocket can be used for entertainment, e.g. fireworks. So these are the uses of rocket. We were asked to list 3, but I have given 5 uses of rocket. Number one, rocket can be used for space travel. Rocket can be used for space exploration. Rocket can be used for warfare. Rocket can be used for launching of artificial satellites into orbit. And then lastly, rocket can be used for entertainment, e.g. fireworks. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 6. What is doping? And the B part of the question says explain how doping improves the conductivity of a semiconductor. Now, semiconductors are materials which have an electric conductivity intermediate in value between that of a pure metal, that is a good conductor, and that of a good insulator. Now, what is doping? Doping is the introduction of impurity atoms into a semiconductor. Doping is the introduction of impurity atoms into a semiconductor. Now, question B says, how does doping improve the conductivity of a semiconductor? Now, doping increases the conductivity of a semiconductor by increasing the number of charges, or the number of electrons, or the number of holes. I'll take that again. Doping increases the conductivity of a semiconductor by increasing the number of charges or electrons or holes. So what is doping again? Let's put it down. Doping is the introduction of impurity into a semiconductor. That's the A part of the question. Then the B part of the question: how doping improves the conductivity of a semiconductor? Now doping increases the conductivity of a semiconductor by increasing the number of charger electrons or holes. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 7. Now the diagram above illustrates a cathode ray tube. Identify the components X, Y, Z. Okay? Now the cathode ray tube components are: X is the filament or heater or the cathode, Y is the anode, and then Z is the plate or the deflector. So we have X is the filament or the heater or the cathode. Then Y is the anode, and then Z is the plate. It's called the plate or the deflectors. Thank you. These are the cathode ray tube components. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 8A and 8B. A. Explain the term net force. B. Define the principle of conservation of linear momentum and state one example of it. Now, what is net force? Net force is the effective or resultant force resulting from the actions of a system of forces on a body. Net force is the effective or resultant force resulting from the actions of a system of forces on a body. Okay, now the second part of the question says to define the principle of conservation of linear momentum and state one example of it. All right, the principle of conservation of linear momentum explains that in an isolated or closed system of colliding bodies, the total linear momentum in a fixed direction remains constant. The principle of conservation of linear momentum explains that in an isolated or closed system of colliding bodies, the total linear momentum in a fixed direction remains constant. An example of that is the recoil of a gun, the colliding trolleys, rocket propulsion, and so on and so forth. Now let's put down a few things concerning net force. So net force is the effective or resulting force resulting from the actions of a system of forces on a body. Then B, the principle of conservation of linear momentum explains that in an isolated or closed system of colliding bodies, the total linear momentum in a fixed direction remains constant. Now example, e.g. we have recoil of gun. We also have colliding trolleys, then we have rocket propulsion. For more videos, I'd like you to visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 8C. A ball of mass 200 gram released from a height of 2.0 meter hits a horizontal floor and rebound to a height of 1.8 meter. Calculate the impulse received by the floor, given that acceleration due to gravity is 10 meter per second. So we have to find, let's find the velocity. V squared is equal to u1 squared plus 2gh, which is equal to 0 plus 2 times 10 times 2. Okay, this is equal to 40. All right, so we have v1 is equal to the root of 40, which is equal to 6.32 meter per seconds. Okay, So we have v squared 2 is equal to u squared plus 2gh h2 now. So this is 0 equal to u squared 2 minus 2 times 10 times 1.8. This is minus. Okay, so this will give us u equal to the root of 36, which is equal to 6 meter per seconds. Now impulse is equal to change in momentum. Okay, so we have this is equal to mv1 is equal to minus mu2 is equal to m v1 plus v2. Okay, so this will give us 0.2 into 6.325 plus 6.00. Okay, so this will result in 2.46 Newton seconds. So we have been able to calculate the impulse that is received by the floor. The impulse received by the floor is 2.46 Newton per second. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 8D. A body of mass 20 grams performs a simple harmonic motion at a frequency of 5 Hz at a distance of 10 cm from the mean position. Its velocity is 20 cm per second. Calculate its maximum displacement from the mean position. 2. Maximum velocity. 3. Maximum potential energy, given that acceleration due to gravity is 10 meters per second square and pi is 3.14. So first, let's calculate the maximum displacement. Maximum displacement, which is v. So we have v equal to angular. So we have r squared minus y squared. This is the same thing as saying 2 pi f, the root of r squared minus y squared. Okay, now this is 2 times 3.14 is given in the question, times frequency is 5, and then the root of r squared minus 0.1 squared, that is the distance. Okay, so r, if you calculate that, r will give you 0.12 meter. Okay, so that's the first one. We have calculated the maximum displacement. Now for the maximum velocity, we have v at maximum is given to be wr, which is equal to 2 pi fr, and that will give us 2 times 3.14 times frequency is 5 and r is 0.12. Now v maximum will give us 3.77 meter per seconds, And finally the maximum potential energy, which is potential energy, is given as 1/2 m angular velocity squared r squared. This is equal to 1/2 m 2 pi f then r squared. Okay, this is the same thing as saying 1/2 times the mass is, if you convert 20 gram to kilogram, you have 0.02 times 2 times 3.14 times 5, let's put this in brackets, okay, times 0.12 all squared. So if you calculate everything put together, the final answer, which is the potential, will be 1.42 times 10 times 10 raised to power minus 1 joules, and that is the answer. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Good morning, everyone. Today I will be answering Waec 2016 Physics Theory Question 9 A, B, and C. Explain the term thermal equilibrium. Fundamental interval. B. List 2 uses of the hydraulic press. Name the materials used to reset the steel index in the 6 maximum and minimum thermometer. Okay, now let's begin with thermal equilibrium. Now thermal equilibrium is a condition in which two bodies in contact have no net flow of heat between them. You know, another name for heat is thermal. So when we talk about thermal equilibrium, we are also referring to heat equilibrium, and it is a condition in which two bodies in contact have no net flow of heat between them. All right. Fundamental interval is the difference in temperature between the lower fixed point, that is the temperature of melting ice at standard atmospheric pressure, and that upper fixed point, that is temperature of steam at standard atmospheric pressure. So fundamental interval is the difference in temperature between the lower fixed point and the upper fixed point. All right, then let's put down a few things about thermal equilibrium. Okay, now thermal equilibrium is a condition in which two bodies in contact have no net force of heat between them. Okay, now fundamental, that's number 2 now in Roman figure. Fundamental interval is the difference between the upper fixed point, and the lower fixed point. Now don't forget that the upper fixed point is the temperature of melting ice the upper fixed point is the temperature of steam at standard atmospheric pressure, and the lower fixed point is the temperature of the melting ice at standard atmospheric pressure. Okay, now having said that, let's look at the B part of the question, talking about hydraulic press. Of course, the hydraulic press is one of the application of Pascal principle. So the hydraulic press can be uses of hydraulic press. Number one, hydraulic press can be used for compressing metal sheet, for compressing metal sheet. Hydraulic press can be used for compressing paper in printing industries, compressing paper in printing industries, Hydraulic press can also be used for lifting of objects, Okay, hydraulic press can also be used for compressing soft materials into bales. Okay, now in answer to the question in C talks about the material that is used to reset the steel index in the SIS's maximum and minimum thermometer. Now the maximum and minimum thermometer is a type of liquid and glass thermometer used by weathermen in meteorological stations. It records both the maximum and minimum temperatures for the day. So I'm going to outline the materials used to reset the steel index in the 6 maximum and minimum thermometer. So the material that is used to reset the steel index in the 6 maximum and minimum thermometer is magnet. Magnet is used to reset the steel index in the 6 maximum and minimum thermometer. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 91. A nursing mother prepared a baby's milk mixture at 85 degrees Celsius in a feeding bottle. In order to cool it to 40 degrees Celsius, she immersed the bottle in an aluminum bowl of heat capacity 90 joules per second per Kelvin. containing 500 gram of water at 26 degrees Celsius. If the mass of the mixture is 300 gram, calculate the specific heat capacity of the mixture. Neglect heat losses and heat capacity of the bottle. Specific heat capacity of water is equal to 4200 joules per kilogram per Kelvin. Alright, so let's begin by saying that heat lost by mixture is equal to heat gain by water plus heat gain by aluminium. So heat lost by mixture is equal to heat gained by water plus heat gain by aluminium. Okay, now so we have mass of the mass, the specific heat capacity of the mixture. We have mass of mixture, specific capacity, then temperature change, that's theta 2 minus theta 1 is equal to the mass of mixture, the specific heat capacity of the mixture, and then temperature change of the mixture, which is theta 2 minus theta 1 plus the specific heat capacity of aluminium and temperature change, which is theta 1 minus the temperature of the aluminium. Okay, so this will have 0.3 times specific heat capacity of the mixture, temperature change 85 minus 40 equal to 0.5, which is the mass of water, times specific heat capacity of water, then temperature change, which is 40 minus 26. Okay, now plus 90, that's the heat capacity of aluminium, then the temperature change is 40 minus 26. This is the mass of water, this is specific heat capacity of water. So this will give us, we have 13.5 specific capacity of the mixture, which is equal to 29400 plus 1660. Now this will be making the specific capacity of the mixture the subject of the formula. We have 30660, okay, divided by 13.5. okay, so if you do that, we would have 221.1 joules per kilogram per Kelvin. So that's the specific heat capacity of the mixture. Thank you For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I'll be answering Waec 2016 Physics Theory question 9D Roman figure 2. Name two ways through which the bottle loses heat. Then name two industrial processes in which heat exchanger is used. Now this question is a continuation of question 9 A, B and C. So this is question D. Question A, part of the 9D, is related to question 9D1 in Roman figure. So the bottle loses heat through conduction and convection, and then the two ways through which the bottle loses heat is number one. Let's write number one. The bottle loses heat through conduction and convection. Okay, so these are the two ways through which the bottle loses heat. Then the B part of the question says to name two industrial processes in which heat exchanger is used. Now heat exchanger is used in incubator, is used in refrigerator, is used in air conditioning, is used in air conditioning, is used in sewage treatment, is used in sewage treatment, is also used in cooling by radiators. Then lastly is used in the generation of electricity, is used. So you can choose from among the industrial processes in which heat exchanger is used. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com for more video. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 10A and B. Now the question says to define critical angle. B. How are antinodes created in a stationary wave? Now critical angle is defined as the angle of incidence in the denser medium for which the angle of refraction in the less dense medium is 90 degrees. Okay, so critical angle is defined as the angle of incidence in the denser medium for which the angle of refraction in the less dense in the less dense medium is 90 degrees. And this is just the diagram. Let's assume we have, let's assume this is the diagram, and then here we have reflection. Now this is the angle of reflection, where the angle of refraction is 90 degrees. Okay, now this is this way. So this is the critical angle, where the angle of refraction in the less dense medium is 90 degrees. Okay, now let's answer the B part of the question. The question says, how are antinodes created in a stationary waves? Now, an antinode is a point on a stationary wave where there is maximum displacement of the medium. Okay, so where there is maximum displacement of the medium. So here we have a maximum displacement. It's a maximum displacement of a stationary wave. So here, this is the antinode, this is a node, this is also a node. So antinodes are created in a stationary wave when an incident and reflected waves are superimposed and 180 degrees out of phase. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 10C. The angle of minimum deviation of an equilateral triangular glass prism is 46.2 degrees. Calculate the refractive index of the glass. Now, the angle of minimum deviation is the angle where the incident and the emergent ray are equally inclined to their respective surfaces. So by measuring the angle of minimum deviation and the refracting angle of the prism, we can calculate the refractive index of the material of the prism. So let's begin by writing the refractive index N is equal to sine A plus minimum deviation over 2 everything over sine A over 2. Okay, that's the sine of the angle. So this will give us sine 60 plus 46.2 divided by 2 over sine 60 over 2. This will result in sine 53 sine 53.1 over sine 30 degrees. This will result in 1.6. So the refractive index of the glass is 1.6. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com for more and more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 10D. An illuminated object is placed in front of a concave mirror and the position of a screen is adjusted in front of the mirror, but no image is formed on the screen. Give two possible reasons for this observation. Now, no image is obtained on the screen because the object, the screen, and the mirror are not coaxial. Also, object is placed at focal point of mirror. The object is placed between the focus and the pole. And another reason is because the screen is located at a distance less than or greater than actual image distance. So these are the possible reasons for this observation. Number one, I said the object, the screen, and the mirror are not coaxial. The object is placed at focal point of mirror, and then the object is placed between the focus and the pole. And then the last possible reason should be that the screen is located at a distance less than or greater than actual image distance. So let's put that down in writing. Now, possible reasons. The possible reasons are: 1, no image is obtained on the screen because 1, the object, the screen, and the mirror are not coaxial. Okay. Number 2, the object is placed at focal point. It's placed at focal point of mirror. Then number 3, the object is placed between the focus and the pole. And then number 4, the screen is located at a distance less than or greater than actual image distance. These are the possible reasons for this observation. Why the object, when placed in front of a concave mirror and the position of the screen is adjusted in front of the mirror, but no image is obtained on the screen. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 10E. Okay, an illuminated object is placed at a distance of 75 cm from a converging lens of focal length 30 cm. Determine the image distance. Then number 2, if the lens is replaced by another converging lens, the object has to be moved 25 cm further away to have its sharp image on the screen. Determine the focal length of the second lens. Okay, so let's begin with the first question. Determine the image distance. All right, so we'll begin by writing the lens equation. Which is 1 over u plus 1 over v equals to 1 over f. Now we have the image distance. The image distance, which is 1 over v, is equal to 1 over f minus 1 over u. Okay, now this will be equal to, now the focal length is 30 centimeter, so we have 1 over 30 minus the object distance, which is 1 over 75. So we can as well write focal length equal to 30 centimeter and the object distance is 75 centimeter. Okay, so this will give us 5 minus 2, everything over 150. Okay, so this will be 3 over 150. So that suggests that our V is equal to 50 centimeter. That is 150 divided by 3. Okay, now for the second part, which is when the lens is now being replaced by another converging lens, the object has to be moved 25 centimeter away to have its sharp image on the screen. So we are to determine the focal length of the second lens. So we have the object distance to be equal to 75 plus 25, which is equal to 100 centimeter. Okay, so let's have the equation 1 over u plus 1 over v equal to 1 over f. So we have 1 over 100, which is the image distance, plus 1 over 50, the object distance, and then we are to find the focal length. So if you solve this problem, we have let's find the LCM. This is 100, so we have 1 plus, that's 2, that's 2. This will give us 3 over 100 which is equal to 1 over F. So we have 100 over 3 is equal to F. So F is equal to 33.3 centimeter. So this is the focal length of the second lens. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 11A and B. Explain briefly dielectric strength. B. An electromagnetic wave has its wavelength shorter than those of radio wave and microwave, but longer than that of visible light. Identify the wave. 2. Name one suitable detector for the wave. 3. Name one source of the wave. Now first, let us discuss about dielectric strength. What is dielectric strength? It is the maximum potential gradient or electric field strength an insulator can withstand without breaking down. I say that again. It is the maximum potential gradient or electric field strength an insulator can withstand without breaking down. It is measured in volt per meter. It is measured in volt per meter. Alright, let's quickly take down what dielectric strength is. Okay, so dielectric strength is the maximum potential gradient or electric field strength an insulator can withstand without breaking down. Now dielectric strength, it is measured in volts per meter. Okay, now the P part of the question says that an electromagnetic wave has its wavelength shorter than those of radio waves and microwaves but longer than that of visible light. Identify the wave. Now the wave is infrared wave. The wave is infrared wave. Now the second question says name one suitable detector for the wave. That's number II, that's 2 in Roman figure, and that is to name suitable detector. The suitable detector can be infrared camera, it can be thermopile, it can be it can be photographic film, it can be photographic film, etc. And then the third question, that's stated in Roman figure, says name one source of the wave. Now the source of the wave can be hot bodies or sun. The source of the wave can be hot bodies or sun. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I'll be answering Waec 2016 Physics Theory question 11C. An oil drop carrying a charge of 1.0 times 10 raised to power minus 19 coulomb is found to remain at rest in a uniform electric field intensity 1200 Newton per coulomb. Calculate the weight of the oil drop. Okay, now let's write the parameters given. The charge, which is Q, is equal to (1.0 times 10 raised to power minus 19), and then we have the electric field intensity, which is 1200 Newton per coulomb. Okay, so electric field intensity is giving us the force per coulomb. Okay, and this is also the same thing as saying the weight is equal to Q. So if you cross multiply, you have the weight equal to EQ, which is the same thing as saying 1200 times 1.0 times 10 raised to power minus 19, and then the weight is equal to 1.2 times 10 raised to power minus 16 Newton. Thank you. For more videos, I'd like you to subscribe to our YouTube website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 11D. An RLC series circuit consists of a 100 ohm resistor, 0.05 H inductor, and a 25 microfarad capacitor. A 220 volt, a 50 Hz main voltage is applied across the circuit. Calculate 1, in Roman figure, the impedance, and 2, the current. Now before we can calculate the impedance, we need to calculate the inductive capacitance, inductive reactance. Now to do that, we have now to calculate the impedance, we have to find the inductive reactance. which is giving us 2 pi FL, and of course the frequency is given to be 50 Hz, and then the inductor is given to be 0.05 H. So if we substitute into this equation, we have 2 times 3.14 times the frequency times the inductor, which is 0.05. The total is 15.7 ohms. Alright, so we have to also calculate the capacitive reactance, which is 1 over 2 pi FC. Okay, and of course the frequency is given to be 50 Hz, and then the capacitance is given to be 25 macrofarad, which is the same thing as 25 times 10 raised to power minus 6 farad. Okay, so substituting, we have 1 over 2 times 3.14 times 50 times the capacitor, which is 25 times 10 raised to power minus 6. So if you do that, we will get 127.4 ohms. Now we can now find the impedance. Now to find the impedance, which is the first one, impedance is equal to, is denoted as Z, okay, and is giving us the root of the resistor squared plus XL minus XC all squared. So we have, this will be equal to the root of the resistor is given in the question. So we have 100 squared plus, if you substitute XL, which is 15.7 minus XC is 127.4 all squared. So let's come to this side and finish it up. This is the root of 100 squared plus, let's have 127.4 minus 15.7 all squared. So the impedance is equal to 149.9 ohms. Now to find the second question says to find the current. So current is equal to V, that's the voltage, over the impedance, and this is volt is given to be 220 from the question, 220, and then we have the impedance, which is 149.9. so the current is equal to 1.47 amperes. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 12A, and the question says explain the following terms. 1. Mass defect. 2. Binding energy of a nucleus. Now, mass defect is the difference between the mass of a nucleus and the total mass of its nucleons. It is expressed in atomic mass unit, AMU. It is also a measure of binding energy. So mass defect is actually equals to the total mass of nucleus minus the mass of nucleon. Now, going to the second part of the question, it says, what is, explain the terms binding energy of a nucleus. Now, binding energy is the work done or energy needed to separate the nucleon in a nucleus. It is measured in evolts or joules. Okay, now let's put a few notes down concerning what has been explained. Now, first, mass defect. Mass defect is the difference between the mass of a nucleus and the total mass of its nucleon. It is expressed in atomic mass unit, AMU. It is also a measure of binding energy. Okay, so therefore we can say that mass defect is equal to total mass of nucleus minus mass of nucleon. Now, binding energy is the work done or energy needed to separate the nucleon in a nucleus. It is measured in electron volt or joules. Joules, that's capital J. Thank you. For more videos, I'd like you to visit our website www.educateafricans.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question 12B1 B2. Question 1 says, assuming the wave nature of an electron, what is the effect of decreasing the speed of a photoelectron on its A, wavelength, and B, energy? Then the second part of the question says a particle of mass 4.4 times 10 raised to power minus 23 kg moves with a velocity of 10 raised to power 5 meter per second. Calculate its wavelength. All right, now this is a continuation of the question 12a. Okay, so the effect of decreasing the speed of a photoelectron on the wavelength is that the wavelength increases, and then the effect of decreasing the speed of a photoelectron on energy is that energy decreases. Is that okay? Now let's put down a few things concerning that. Now the first one, the effect of decreasing the speed of a photoelectron on wavelength is that the wavelength will increase. Then the effect of decreasing the speed of a photoelectron on energy is that the energy will decrease. Okay, now in answering to question number 2, now given that mass is equal to 4.4 times 10 raised to power minus 23 kg, and then we have the velocity is 10 raised to power 5 meter per seconds. Now we have to calculate the wavelength. Is unknown. The wavelength is unknown, and then we have the Planck constant to be 6.6 times 10 raised to power minus 34 joules seconds. So using the formula, wavelength equal to the Planck constant over the mass and the velocity. So this will result in, this will be 6.6 times 10 raised to power minus 34 upon the mass 4.4 times 10 raised to power minus 23 times 10 raised to power 5. So our final answer would be 1.5 times 10 raised to power minus 16 meter. And that's the solution to the question 12b, Roman figure 1 and Roman figure 2. Thank you. For more videos, I'd like you to visit our website www.educateafrican.com for more videos. Thank you. Hello and welcome. Today I will be answering Waec 2016 Physics Theory question number 12C, continuation of the old question in number 12. Now, the diagram above shows part of a radioactive decay series we are to use it to answer the following questions. Now from the diagram, we are to name a pair of isotopes. Number 2, we are to name the isotope with which the series starts. Then number 3, we are to write down a nuclear equation for 2 examples of each, alpha decay and beta decay. Okay, so let's begin with pairs of isotopes as can be seen from the figure. So we have the first one. So let's begin with here. That's I. We have pair of isotopes in the figure are 208, 82. Then we have lead and we have 212, 82 lead, or we have 212, 84 polonium and 216, 84 polonium, or 224, 88 radium and 288, 88 radium, or 288, 90 uranium and 232, 90 uranium. Okay, so these are the isotope with which these are the names of pairs of isotopes as can be seen in the diagram. Now the second part of the question says, it says name the isotopes with which the series starts. The series starts with isotopes 232, 90 uranium. All right, and then the third part of the question says to give 2 examples of each of alpha decay and beta decay. So for alpha decay, we have 232, 90 uranium result in 228, 88 radium plus alpha helium, alpha particle plus energy. Then we also have 228, 90 uranium. We have 224, 88 radium plus alpha particle plus energy. We also have 224, 88 radium We have 220. We have 86. Plus alpha plus energy. Okay, now let's look at, that's the much we can take for that. Let's look at beta decay. Beta decay. Okay, we have 2, 2, 4, 88 radium equal to 224 89 plus O minus 1 electron plus energy, and then we have 228 89 okay, resulting into 228 90 radium plus minus 1 electron plus energy. So I'll give you one more. 212 82 PB, that's lead, resulting 212 83 plus 0 minus 1 electron plus energy. Give you one more. 212 83 PI, resulting into 212 84 polonium plus electron plus energy. Thank you. For more videos, I'd like you to subscribe to our website www.educateafrican.com. Thank you.